Your heart is beating faster than it should. Your hands are slightly cold. Your mind is already 3 steps ahead, running through everything that could go wrong, and nothing has happened yet. This is anxiety, and if you're watching this, you already know exactly what it feels like. What you probably don't know is why your brain does this. Not as a character flaw, not as a weakness, but as one of the most sophisticated and ancient survival systems ever built by evolution. Understanding it won't make it disappear, but it will change everything about how you relate to it. For most of human history, anxiety was considered a moral failing, a sign of weakness, a lack of faith or courage or willpower. That diagnosis was wrong, and it was wrong in a way that made anxiety significantly worse for almost everyone who experienced it, because when you add shame to fear, you don't eliminate the fear. You give it a second layer to hide behind. Based on findings from large-scale population surveys, approximately 1/3 of individuals will experience an anxiety disorder at some point in their lives. 1 in 3. That's not a character flaw spread across 1/3 of humanity. That's a biological vulnerability distributed across a species, and understanding the difference between those two things is the first and most important step toward living with anxiety rather than being imprisoned by it. Anxiety is not what you feel because something is wrong with you. It's what you feel because something very old and very powerful inside your brain is trying to keep you alive. To understand anxiety, we need to go inside the brain. At the center of everything is a small, almond-shaped structure called the amygdala. It sits deep in the temporal lobe, and its primary function is one of the most important in the entire nervous system: threat detection. The amygdala receives sensory information from the outside world, what you see, hear, smell, feel, and evaluates it for danger. When it detects a potential threat, even a hypothetical one, even an imagined one, it triggers an immediate cascade of biological responses that prepare your body to fight, flee, or freeze. Heart rate accelerates. Breathing becomes shallow, muscles tense, stress hormones flood the bloodstream. This is the fight or flight response, and it was designed for a world where threats were physical, immediate, and short-lived. Recent studies have expanded our understanding of anxiety's neural architecture beyond the amygdala alone, identifying a broader network that includes the bed nucleus of the stria terminalis and the lateral habenula, with the hippocampus storing fear and long-term anxiety signals that can be reactivated by a similar context, even when the individual is no longer directly in that situation. This is the crucial detail that explains modern anxiety. The hippocampus doesn't just store factual memories, it stores emotional ones, the feeling of danger associated with specific contexts, people, or situations. And those stored danger signals can be reactivated by anything that resembles the original threat, even years later, even when the original threat no longer exists. Your brain is not stuck in the past because it's broken. It's stuck in the past because it's protecting you from what hurt you before. When the amygdala fires, it doesn't just send a signal. It activates a system. The hypothalamic pituitary adrenal axis, or HPA axis, is the body's primary stress response system. When the amygdala perceives a threat, the hypothalamus releases corticotropin-releasing hormone, which signals the pituitary gland, which in turn signals the adrenal glands to release cortisol, the body's primary stress hormone. Cortisol does several things simultaneously. It increases blood glucose for immediate energy, raises blood pressure, suppresses the immune system to redirect resources toward survival, and heightens sensory alertness. In short bursts, this is life-saving. But the pathophysiology behind anxiety is rooted in the interplay of neurobiological, genetic, and environmental factors, with stressful experiences during early development, leading to the sustained activation of the HPA axis that can extend into adulthood, increasing vulnerability to anxiety disorders and emphasizing the long-term impact of early developmental stress on mental health. When the HPA axis is chronically activated, when the stress response never fully turns off, cortisol levels remain persistently elevated, and that has measurable consequences. impaired memory consolidation, reduced immune function, disrupted sleep, increased cardiovascular risk, and a progressive lowering of the threshold at which the amygdala fires. In other words, the more anxious you are over time, the easier it becomes for your brain to generate anxiety. It's not a character failure. It's a biological feedback loop. Not all anxiety is the same, and understanding the distinction matters enormously. Anxiety in its healthy form is adaptive. The nervousness before an important presentation, the vigilance while driving in difficult conditions, the worry that motivates you to prepare for something difficult. These are functional responses, the brain doing exactly what it was designed to do. Anxiety disorders are something different. They occur when the threat detection system has become decoupled from actual threat. When the amygdala fires at stimuli that don't represent genuine danger with an intensity disproportionate to the situation, in a pattern that is persistent and that significantly interferes with daily functioning. The Diagnostic and Statistical Manual of Mental Disorders identifies several distinct anxiety disorders. Generalized anxiety disorder, characterized by chronic and excessive worry across multiple domains of life. Panic disorder with sudden, intense episodes of physical terror. Social anxiety disorder involving profound fear of social evaluation, and specific phobias, among others. What unites them is not the content of the fear, but the mechanism, a nervous system that has learned to generate danger signals in contexts where danger is not actually present. And critically, a 2025 review published in Frontiers in Neural Circuits identified novel therapeutic agents, including selective serotonin receptor partial agonists, that hold significant potential in the treatment of generalized anxiety disorder, representing a significant advance in how we understand and treat the neural circuits underlying anxiety disorders. The science is advancing, the treatments are improving, and the stigma, the idea that anxiety is weakness, is increasingly incompatible with everything we know about how the brain actually works. Here is the deepest paradox of anxiety in the 21st century. The brain that generates anxiety was built for a world that no longer exists. For hundreds of thousands of years, the threats that activated the human stress response were physical and immediate. Predators, rival groups, starvation, environmental danger. The anxiety response was perfectly calibrated for this world. It activated fast, it helped you survive, and it turned off when the threat passed. But we no longer live in that world. The threats that activate the modern human's amygdala are almost never physical and immediate. A difficult conversation that hasn't happened yet, a financial situation that might deteriorate, a health concern that might or might not be serious, a social situation in which we might be judged. The brain cannot tell the difference. A difficult email from your boss activates the same neural cascade as a predator emerging from the undergrowth. The cortisol floods in. The heart rate rises. The muscles tense. And then nothing happens, because there is nothing to fight and nowhere to run. The stress hormones have nowhere to go. The energy mobilized for survival has no outlet. And the system remains activated, waiting for a threat to materialize that never comes, because the threat was never physical to begin with. This is the fundamental mismatch at the heart of modern anxiety, ancient hardware running in a world it was never designed for. The neuroscience of anxiety has advanced dramatically in the last decade, and with it, our understanding of what actually helps. Cognitive behavioral therapy remains the most evidence-based psychological treatment for anxiety disorders, with meta-analyses consistently showing response rates of 60 to 70% across most anxiety disorder categories. The mechanism is precise. CBT works by systematically exposing the nervous system to anxiety-provoking stimuli in a safe context, allowing the amygdala to learn that the anticipated threat does not materialize. Every successful exposure slightly lowers the amygdala's sensitivity, the reverse of the sensitization process that created the disorder. Mindfulness-based interventions work through a different but complementary mechanism. By training sustained, non-judgmental attention to the present moment, they strengthen the prefrontal cortex's capacity to regulate amygdala activity, the top-down control system that anxiety disorders progressively weaken. Physical exercise has consistently demonstrated anxiolytic effects across multiple controlled studies. Regular aerobic exercise reduces baseline cortisol levels, increases BDNF, the protein that supports neuronal growth and plasticity, and improves sleep quality, which is itself one of the most powerful regulators of emotional reactivity. And perhaps the most counterintuitive finding of recent anxiety research. A 2024 study found that even simply rebalancing specific brain circuits can reverse anxiety, suggesting that targeted neurological interventions may eventually make it possible to address anxiety at its biological source rather than only at the level of thought and behavior. The brain that learned to generate anxiety can learn something different, not through willpower. Not through forcing yourself to stop feeling what you feel, but through deliberate, evidence-based engagement with the very systems that generate the anxiety in the first place. Anxiety is not your enemy. It is your brain's oldest and most persistent attempt to keep you safe, running on software that is hundreds of thousands of years old, in a world that has changed almost beyond recognition. Understanding this doesn't make the anxiety disappear. The racing heart, the racing thoughts, the feeling that something is wrong even when nothing is. Those experiences are real. They deserve to be taken seriously, not dismissed. But there is a difference between taking anxiety seriously and believing everything it tells you. Your amygdala is not always right. It is vigilant, it is fast, and it is ancient. But it cannot distinguish between a predator and an unanswered email, between genuine danger and a difficult conversation, between something that will hurt you and something that simply feels like it might. Learning to make that distinction yourself, with patience, with practice, and when needed, with professional support, is perhaps the most important psychological skill a person can develop in the modern world. Your brain won't let you rest because it cares about your survival. The work is teaching it that you are already safe. Thank you for watching until the end. Subscribe if you want more psychology videos like this, and let me know in the comments. When does your anxiety show up most, and have you ever found something that actually helps?